Hi, welcome to Cilium Weekly, episode number 43. Cilium Weekly is a weekly show, kind of weekly, where I talk about a new Cilium feature. And today I'm going to talk about Multicast on Kubernetes using Cilium. Now, if you're not familiar with Multicast, that's okay. I'm going to give you a quick recap, and then later on, 5 minutes, we're going to go through a demo using the new enterprise edition of Cilium. Now, Multicast, right? So in the late 80s, what happened is you had this engineer called Steve Deering who was working on a project where he was required to send a message from one computer to a group of computers across a layer 3 network. And his research led him to realize that there was no routing protocol that supported this functionality. So he decided to write his doctoral thesis on IP multicast, and is kind of known as the inventor of IP multicast, and he also happens to be the lead designer on IPv6. So quite impressive background here. And all this, I found this in a book I've been consulted a lot over the years, CCIE Routing and Switching Guide, which this one is about 15-20 years old already. So really, IP multicast is about sending a message from a single source to selected multiple destinations in a layer 3 network in a single data stream. Now, how does it differ from unicast and broadcast? And and let's just use like normal terms and analogies to understand it. Unicast, it's like making a phone call to your buddy. It's like it's a message from one source to a destination, right? Broadcast is like using a loudspeaker to talk to everybody in the street in your local area, right? That's essentially you send. It's a message sent from one source to all destinations on the local network. And multicast is more like listening to a radio station or subscribing to a podcast, right? It's essentially sending one message from one source to a selected number of members that decided to subscribe to a group. Again over a routed network in a single data stream, and that's the key thing. Now, if we look at a couple of different diagrams here, if you look at this one, it's unicast, where let's say I've got pod 2 and pod 4 here, and this is for Kubernetes, but that also works for normal IP networks. Think of them as subscribers for the traffic that this source pod has to send. And in unicast, to deliver the traffic to pod 2 and pod 4, they would send one packet to pod 2 and then the same identical packet to pod 4, right? So it's not super efficient. And obviously, if you get like 100 nodes in your network and maybe half of them are interested and half of them are not, then you have to send 50 copies across the network. So not efficient at all. And then you have broadcast, where imagine again if you have the same 2 pods interested and 2 pods not interested in that traffic. What broadcast would do is broadcast doesn't care. It'll just send send a packet and will be replicated across to every endpoint, regardless or not they're interested in the traffic. Again, not an efficient use of the bandwidth. And finally, multicast is where you would only send the traffic to the interested parties, but you would just send a single flow, right? You send a single packet, and then the network will ensure that packet is replicated and sent to the right subscribed devices, pods, endpoints. So that's it for the quick overview of multicast. And now let's go straight into a demo. I'm going to be using Cilium, the enterprise edition of Cilium offered by Isovalent. There is some multicast support within the open source edition. It's just the data path. You can program it using the Cilium CLI within the Cilium agent. But the enterprise edition provides fully managed capabilities, as we're going to see. So what I've got here is in my demo environment, I've got multicast enabled. So the data path is enabled. Now, if I want to create a multicast group, which is essentially the IP addresses, multicast IP addresses that my subscribers will be listening on, will be a part of, I can create it using this isovalent multicast group CRD, which you can see is pretty simple. You just specify the IP addresses of the multicast groups that you want to join. Now, I'm going to go ahead and, as you can see, I'm using one of our isovalent labs for this demo. And I'm just going ahead, deploying my multicast groups. And what I'm going to do next is I'm going to just double check in the BPF maps that, if everything has been configured. I can see that I've got my 3 groups created, which is great. Now, if I look at the subscribers, I don't have anybody yet who's interested in that traffic, right? So I've got nobody interested, and we're going to join the multicast groups. Now, in IP multicast, the protocol that we used to join and to tell the network that we are interested in the traffic is called IGMP. That's IGMP v2, IGMP v3, and they're both supported by isovalent Enterprise for Cilium. So I'm going to deploy a pod here, and as you can see, we're going to run a command, a socat command, to say I'm joining the multicast group 225.0.0.11. The pod is running, and if I look back into my BPF map, so my pod has been deployed, and now we're going to go and again log back onto the Cilium agent and see that this pod, this is our subscriber pod with that IP, is now listed as a subscriber. So we've kind of snooped the IGMP method and say, okay, this is an endpoint which is interested in that stream. So multicast is working, we think, according to some of the data on the BPF maps here. Now let's verify. We're going to look in the demo. We're going to deploy a few pods, and we're going to again send some stream to the multicast IP address, and we're going to see what happens. So what I've got here is I'm deploying a deployment of 4 pods. It's again using the NetShoot container, which is great as all the kind of IP utilities like TCP dump, for example. So let's have a quick look. I've got my pods here. Here we go. They're all running. So I'm going to use the first one. That's going to be my source pod. Is going to emit some multicast traffic. This one is going to be my subscriber, one of my first subscriber, and subscriber 1. And it's going to join the multicast group. And I'm going to have another one. And then I'm going to have this one, which is not going to be part of the multicast group. Right? I just want to show you that it is not receiving the traffic. So what I'm first going to do is I'm going to go here, and I'm accessing the shell of my of that pod, which is this one here, FX9C, and again I'm subscribing to the 225.0.0.11 multicast group. Now on the same pod, what I'm going to do here is I'm going to run TCP dump. Now, again, when I send some traffic to the multicast IP address, I should see some traffic appearing here. Now we'll go to another pod. Again, we will subscribe here, and we should expect to see some traffic. And then we're going to go to the third pod, which is the last one on here, 6477, And again, we're going to be running TCP dump, and here we don't expect to see the traffic. And finally, we'll go back to the original, the first one here. And we're going to send some traffic. Again, we're going to send the hello multicast message to the 225.0.0.11 group over port 666. Now, our subscriber 1 has received the traffic. Subscriber 2 has received the traffic, hello multicast. And again, if we look back on the subscriber 1 at the output of the TCP dump, we can see, again, a package sent from our source pod has been sent to the 225.0.0.11 multicast IP address. And then the non-subscriber has no multicast traffic. There's just some ICMP going around. So, and that's it really. That's just multicast is kind of a publisher-subscriber model, right? Where we just, if you're interested in the traffic, you tell the network, I'm interested. The network will manage the memberships, who's interested, who's no longer interested, and will take that initial flow and will replicate to all interested parties. And we now support this using ISO Enterprise. Thank you very much for watching, and I will see you in the next one.